this chart of the results minus what we thought was a special cause, but ended up to be a completely different season and not comparable in context. And we, David, what are you seeing here? I mean, since you're the person who haven't read, let me pick on Travis for you. Travis, when you look at this, seriously.
Well, I don't see any signals of a change based on the rules that you used, and I don't see 1 sigma or 2 sigma to make any other inferences, but probably that wouldn't change anything.
Yeah, it looks just like ordinary random variation, doesn't it? It's within the lines. There's no patterns. It's just what happens. What this particular process is designed to do, and it's really quite stable. The theory is that all process behavior will have an upper and lower limit of predictable behavior, but most of the results will be closer to the center line than to the edges in a stable process or in a predictable process. And it kind of looks like it. I mean, okay, you have a few that seem to be a little farther away, but most of them are pretty close to the center line. So the only thing you can learn from this chart is that you have a stable process and that you can define the behavior of that, the predictable limits of variation. The nice thing about it is it's very predictable, and that makes it actionable. That means that we can predict probably on the 9th of April, the 16th of April, until we come to one of these holiday seasons, this is pretty much what the behavior is going to do. And it changes completely the way we look at how we manage. Because the ad item really, all this time we're spending every week and all this going back and forth and making up reasons and reacting is really giving away margin. It doesn't really make a difference. In fact, we kind of are wasting our resources based on this chart of the process behavior. Based on this, Raphael, do you think it makes sense to have the ad meeting?
Apparently not.
Exactly. Now, this is very important because this is what companies are doing all the time. They're chasing the wrong mule.
Can I ask a question?
Yeah, sure.
I mean, there could be a special cause of variation that just doesn't push something necessarily beyond the control limits or to one side or the other of the average, right?
That's a good question. Well, here's the thing. There could be, I suppose, but as long as you're within those limits, it's very highly unlikely. The numbers in terms of probability, and I don't want to go into it, are almost 98% of all variation that you see is statistically is common causes. This is random chance variation, ordinary variation. It's built into the system. It's natural to the way the system was built in. Actually, special causes are very few because the cause has to have a lot of force and overcome some hundreds of little things that are varying all the time. And so, based on experience, in particular in manufacturing and many years of experience, in general, only a very small percentage of the variation that you see is special cause. And the price you pay for treating a ordinary variation as if it was a special cause is too high to risk it given the numbers. So maybe every once in a while a little special cause might sneak in, but don't worry, it'll come back in later and maybe get more powerful and you'll catch it. But if you start thinking of the control chart as anything but if it's outside the lines, or if you have an end balance over the center line, or you have a trend in one direction, then you get into a very gray area that can have an economic effect. The point's not to be right, it's to be economic, to use your resources as wisely as possible.